Welcome, this is Algebra 2, Semester 1, Unit 2, video number 4, Shift Happens. This is a transformation. In this video, we've been kind of playing around with these graphs. This is a linear graph again. I would expect you to go ahead and fill these in on your own, the domain and range. We do want to kind of keep an eye on what happens with these today. So, we're wanting to shift horizontally. This is like in our little cartoon figure. If you were standing, like in a grocery line, let's say getting ready to check out, the clerk's standing here, she's like, okay, I'm helping you, and then boom, the next second, you're out by your car. You're going, whoa, what happened to me? How did I shift from here over to here? It's just so cool because we can do this graphically, and what you can't do in the real world, sometimes you can do mathematically, and it's like, this is so awesome. So we're going to take this parent graph here, and we're going to shift him. We want to shift him to the left or to the right. So we have the point 1, 1. What we're wanting to do is, let's say we're going to beam him over to the right. So let's go 1, 2, 3, 4. Let's go 4 to the right. So we want the output, we want this shift to become 1. Let me think this through. We want that shift to change our x to 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5. 5. We're going to move them 4 to the right. So let's just make a note here. We're moving 4 to the right. And then we still come out with the y value of being 1. So this is like a really manipulative type of a relationship, because y is not wanting to change, but oh man, she's wanting that x to change like inside his brain. So we know the numbers in the front caused a stretch and a shrink. The sign in front going to a negative caused a reflection. So now we've got a clue here where we're saying, hey, this is going to happen inside of x. It's like it's happening in his brain. So let's just try something. Let's take x and move 4 to the right here. Now, moving to the right, in class I've always referred to going to the right as positive and going to the left as negative. So let's try this and see if this works. We plug in 1 for our y, or for our x, and we end up with 5 for our y. So that didn't really work for us. We really want to plug in that 5 and end up with 1 on the x. Here we went this way. So how could we end up with a 1 and have 5 plugged in for x? Well, going back to our t-chart when we used to play the input-output game, if we input 5 and we end up with 1, we're just taking this and we're subtracting 4, aren't we? So now let's try this. If we subtract 4, we get that 5 minus 4 is 1. We just moved that 1, 2, 3, 4, 5 up to 1. We just moved that over to the right 4 with a -4 in there. Is that wild or what? Okay, so let's try it with 0. 0 minus 4 would be, plug 0 in there, we subtract 4, we get 1. Oh, I'm sorry, I took that. We plugged 5 in, and we got 1. Oh, that is right. Whew, I'm having this brain fart now that I'm talking about this. Now let's go to 0, and we have minus 4 is -4. So if we go to 0, 1, 2, 3, 4. What about 1? If we plug in 1, minus 4 is -3. Whew, we did some moving. Now we know that it's linear, so we can just connect our line and look at what happened here. These numbers are kind of baffling sometimes when you look at them. So we took our parent function, and it was at 1, 1. We were trying to move it over here and just shift it like this transformation, like we're talking about with you in the grocery store. Boom, you're out in the parking lot. We're just trying to shift him over. And look at what we did. We did shift him over to the right. We took those points and we shifted them right, but we did it by an equation that looks like it would go left almost, because we did a -4. It's kind of like inside his brain, it did the opposite action when it was inside X. So let's just try this. Let's go with a different color, because this is so cool. Y equals X plus 4. Now my guess is, if we're messing inside of his head, which these parentheses can be kind of like his head, inside here, just messing right with the X, my guess is where -4 went right, what do you think positive 4 might do? Let's try it. We plug 1 in for X. 1 plus 4 is 5, so we go to 1, 1, 2, 3, 4, 5. Now let's go with 0. 0 plus 4 is 4. And now, because it's linear, we can connect these lines, and holy smokes, it does look like we shifted our parent graph over to the left 4. Now you might say, oh, that looks like it's going up. I will tell you that I'm influencing you just a little bit, because I've seen this happen before when I played around with the absolute value. So let's move down here and you'll see the shift really right and left. It's a little bit clearer with absolute value, how it goes right and left. So we have our absolute value, and we say, well, because we know that we messed around right inside of the boundaries of X on our linear, we messed around inside the boundaries of X. Let's do that again. Let's put the -4 right inside the boundary. Now in the linear, it went right. So my guess is, if I do this again, following the patterns, it's going to go right. So in other words, this V shape here that we have in our parent, it's going to move over here. 1, 2, 3, 4, 5. Well, let's just try that. Let's plug in 5 for the X. If we're correct in our thinking, then this vertex should be down here at 0. Okay, so we go 5 minus 4. Oh, we get it at 1. So my thinking's off a little bit. Instead of that being at 0, 1, 2, 3, 4, 5, it's up at 1. Well, why might I be off? Oh, I see that I miscalculated, only because I forgot that I was shifting it only 4. So if I'm moving it to the right 4 units, that 0 would be at 4. Let's try that. 4 minus 4, that is 0. So there we go. We've got our V started right here. Let's go with 3 minus 4. Well, 3 minus 4 ends up being -1. Absolute value of -1 is 1. So we see the shift. We see our V-shaped parent graph shifting it just shifted from 0, 0, it shifted over 4 units, right 4 units when we put that -4 in there. Okay? So now I bet we could do some guessing here. What if we put y equals absolute value plus 4? I want you to plug in points and see. So if we plugged in points, my guess is where this one went right 4, what's this one going to do? I'm thinking it's going to take that parent graph and shift it left 4. So wild how they're opposite inside. You know, it's kind of like in your brain. I've heard before that if you get your brain damaged on the left side, that it affects your body on the right side. And this is kind of like inside the X brain, evidently. So we plug in, let's just plug in this -4. -4 plus 4. Ho-ho! It is absolute value of 0, so it's 0. So at -4, 1, 2, 3, 4, we're at 0. -3 plus 4 would be 1, absolute value of 1. Ah, there comes our V. Is this cool? Isn't that awesome? So we see that this was a left shift 4 units. Forgive me that I didn't use the ruler that time. Getting too excited. Okay, so what I want you to do is I want you to complete these notes. I want you to go with a right shift using this quadratic formula. And remember, you've got to be inside with the X. So I'm not going to tell you what it is. I will tell you use parentheses. You have the square outside of it. Okay? Then, and I want you to go, let's go 6 units. Right, 6 units. So in other words, if you picture this, it's going to go from the parent graph, it's going to go right 6, 3, 6. It's going to be right there. So you do what you think you need to do to this equation, and then plug in points and make sure it comes out right. Okay, and then I want you to do on that same graph, I want you to do left 3 units. Y equals, I'll give you the parentheses again. Okay, and so left 3 units, you're going to take your parent graph, and remember it's just x squared, and you're going to move it 3 units left. So it's going to be over here. Cool, huh? So this is for this one, and this is for that one. And I want you to give me the equation. Come to class and show me that equation. Now with the cubic, I'm going to do something different. I'm going to give you equations. I want you to do this. I want you to figure out where this one is. And you may have to plug in a lot of points to figure this out. Or if you've been catching on to the pattern, you'll be able to draw it right away. I always look at the cubic having the vertex right here, this kind of a straight line of 3 points. And that's what I actually manipulate left and right. So that might help you. But I want you to do this. I want you to graph x minus, let's go 7 cubed. And tell me what the shift is. Write it up here and then graph it. And then take the y. And on another graph, go plus 2. And show me where it'll be graphed and how it shifted. We know it'll be left-right because of the fact that we've gotten inside the x's space there and we're influencing. Then come down here, I want you to identify domain and range, horizontal shifting with these. By the way, I want to go back up and talk about domain and range. With the linear, when we shifted left, right, did we make any limitations? No. So it's still all real numbers on both of those. Now on the absolute value, remember our limitation was that y is greater than or equal to 0. The domain is all real numbers. When we come over here, we notice y is still greater than 0, isn't it? So we haven't made any effect on our domain and range in making horizontal shifts. And that's a pattern that we can see even when we come down to the quadratics. It's still going to be y is greater than or equal to 0, just like the parent function was. Okay? Kind of important to notice. And so when you get down here, I do want you to identify domain and range on these. And I do want you to explain the horizontal shift simply by examining the equation. You shouldn't have to always graph these now. You can see the pattern. Okay. In class, you will do page 8, or you can do it right now and just practice, but I'd like you to do it in class with me just to make sure that you have it right. I just gave you a few graphs there, and then we did some transformations here. So do that in class. Let's go on to page 9. Page 9, now we're going to look at vertical shifting. Vertical shifting is so cool. Back when I was a kid, there was a really cool show that my sister watched a lot, Star Trek. I didn't really care for TV. I couldn't sit still to watch it. So I went out and rode bikes. But there was this guy on Star Trek. He'd be like standing there, and it was so cool. He'd be like in the world wherever he was at, and he would talk into his little microphone and be like, "Beam me up, Scotty." And instantly, I mean, people would be standing there interacting with him, and instantly he'd be gone, you know? Kind of like in the Bible when they talk about, you know, the rapture. It's like, whew, people are just taken up. So it's cool to think of. We don't see it in our reality around here, but we know that it's possible. There's, you know, been historically just people that you hear stories, and some of it's not hearsay, it's documented, and that they're taken up. And so that's a vertical transformation. In math, we can show it all the time. We can show it by going up. Now, we know the other day that when we played with these parent functions, I've got the linear parent function already drawn. You need to pause the video and go through and draw all of these parent functions. If you're having trouble drawing those, make sure to see me. They should be pretty simplified by now. So I want to go to absolute value first, because sometimes I think these shifts are hard to see with linear, and that happened on our last one. But on absolute value, we just want to shift it up now. We want to take this 0, we want to go up 1, 2, 3, 4, let's say 5. We want to go up there and have it shift just straight up. We're going to beam them straight up into the sky. So we take our y, absolute value x. Now what we have learned, if we put a negative, it flips over that x-axis. If we put a fraction here, it shrinks it down. And if we put a whole number or an improper fraction, it'll stretch them up. And if we mess inside of the x space, kind of like inside of his brain, we saw that if we put negative in there, it shifts the graph positive horizontally. If we put a positive in there, it shifts it negative horizontally. Sorry, I just shifted wrong. I have a lot of trouble with lefts and rights, so I apologize there. But if we put a positive in, it shifts left. If we put a negative inside there, it shifts right. So where's the only other place that we could put numbers? We know in front, we know inside. How about after? Now, I don't know if it'll be a positive 5 or a negative 5, but I'm going to risk it that it's a positive 5. Because we're not inside. You know, when you're inside with that X, it's like being inside somebody's brain or looking in somebody's house, you know, not being weird, but when you're walking down the street and you look in a window, you don't know everything going on in there. And that's part of the reason that that shift was backwards. But when we're on the outside, I'm going to trust that we can see it nice and clear. It's going to go the direction we say. Let's just try this. So at 0, we had 0, 0 in our parent function. Now we plug in 0, absolute value 0, plus 5. Whew, voila. Goes 0, 1, 2, 3, 4, 5. Cool, we just beamed them up. We plug in 1, the absolute value of 1 plus 5 would be, absolute value of 1 is 1, plus 5 is 6. And look, we just took that parent function and beamed them up. Okay? Pretty cool, huh? Now, if we can beam them up, obviously, we could cast them down too, couldn't we? So we have it at 0, 0. All of a sudden, we could say, hey, let's just sink him, you know? Be like the practical joke on this little, I don't even know who that guy was in Star Trek that said, beam me up, Scotty. But what if Scotty did the practical joke of instead of beaming him up, he just whoosh, sunk him right into the ground? So let's go at -5. 0, absolute value of 0 is 0. -5 would be right down here. 1 is 1, -5 is 4. Look at, we just did our practical joke. When he said beam me up, we just sunk him right into the ground. So you can go up or down. Up, you have the positive afterwards. Down, you have the negative afterwards. Okay? Let's go ahead and do the cubic on this one. So the cubic, here's our parent function. I told you in the last little section to watch that vertex right there. That's a really helpful vertex to have. So now we're going to try the same thing, assuming patterns work in math oftentimes. We have x cubed. We don't want to get inside his space. We know that's a left-right shift. But let's go after him. Let's go up plus, let's make it plus 2 this time. So we know 0 cubed was 0. So 0 cubed is 0. Plus 2 would be 2. We just shifted that up 2, didn't we? 1 cubed was 1. 1 plus 2 is 3. -1 cubed was -1. Plus 2 is +1. So see how this vertex, that turning point on the graph, just shifted up to, we just beamed him up. So that's an up 2. Okay? If we want to go down 2, we would take this parent graph and we would subtract 2. So now you know how to run the controls like Scotty, and you can beam lines up, beam lines down. You can mess around any way you want, beaming them wherever you want now, because you know the shifts left, right, up, down. You can flip them. You just have some fun with it. So this is a down 2. Now I do want to mention one thing, is on these shifts, the domain wasn't affected, was it? It still goes side to side. But look at what happens. The range for this one. Now we can bring this lower limit clear up to the 5, can't we? So our range is y is greater than or equal to 5. Here, our range would be y is greater than or equal to -5. So watch that. One thing that you should make a note of is in the controls, I'm just going to use a piece of scratch paper here. In the control room where Scotty's setting is, he's got a keyboard here where he knows exactly what levers are doing what. You guys already do this with video games all the time. And I can't believe how well you can run video games. But you know pushing the knob left or right, what it does, up, down, pushing it in, all of those things. Here's what his control panel tells him, is there's a positive or a negative button here in the front. The positive will make it regular, like the parent function, but the negative will reflect. So if he simply wants to reflect it, he just pulls in that negative, punches that in first. Now, the number here, we'll just call it A. That number here, remember, on the first day, that we were looking at these, if the value was a fraction, less than 1, now we don't care if it's negative or not, we're just looking at the absolute value, then remember it shrunk it, or it shrinks to the x-axis. If you want to just leave it like the parent function, then just leave it equal to 1. That would just be regular. And if we made it a big number, remember we could stretch it off of that x-axis. It was like stretching those kids, clear off of the x. So now whatever we have around it, if we have the x just by itself, that's the straight line, that's the linear. If we have the absolute value around the x, that's the V shape. If we have the squared around the x, that's the U shape. And if we have the cube around the x, that's when it did that muscle man pose. Okay? And it's kind of fun if you're in class, you know, we do some dancing where we can do all the different poses with that. And you can just, if you're not in my class or if you're on your own, you can just practice every so often, you know, being funky and dancing. Dance to math. I mean, you can do all these different designs with your hands and have some fun, you know, shout out, you know, cubic and get into the muscle man pose, squared, the U shape, the V shape, and so on. Okay, so I'm just going to choose just parentheses around this, meaning that it's linear, but it works on any of them. If we get inside, in the space with x, remember, that was kind of inside his head kind of a thing. And if we damage our brains on the left, it affects our movements on the right. It's the opposite. So if we have a negative h, the shift is positive. Shifts right. And if we have a positive h, it shifts left. Okay? Now, the very last thing that we just discovered is we have out here, we'll just call it a K. I mean, all formulas, all control panels, even on your Xbox, you just have letters and symbols. So we're just going to use these symbols as our universal of what we're talking about. And positive K, we just discovered goes, if it's positive, it goes up. If it's a negative, it's going to go down. So I suggest that you just make your own little control panel, memorize that. I didn't give you very much vocab for this section, so just memorize your control panel, the different shapes around here, cause the shapes of the graph, and then what each of these levers does. Okay? Going back to page 9 now, we just shifted that one up. I don't want to bore you with this video. If you shift down, you would graph it right down here. 0 would become -2, and you'd graph that kind of a transformation. These are not a difficult thing. You guys are masters at it where you play the video games. You've got this math, so let's just have some fun with it now. I do want you on this one. Let's do a quadratic. Could you please graph the quadratic shifting? Oh, let's send him. Oh, let's go way, way down into the ground. Let's go at a -9. And I just flipped those. I'm so sorry. That one's going to be your downshift. This is going to be your upshift. Let's go x squared plus 3. And then on the linear, I'm going to just give you a couple of graphs. This one, I'm going to change the vertex up here to a +6. Go ahead and draw it on yours. Can you please give me the equation for that +6? Y equals, remember no parentheses this time, you're just going to give me the value that you shifted up. And then on this one, I want to see the downshift. Whew, I almost did something funky there to you. I bet you could handle that. Let's go down, 1, 2, 3, 4, 5, 6. And let's do a reflection while we're at it. So this time we played a real practical joke on the guy. He said, beam me up, Scotty. And we went, oh, let's sink him. Let's put him down 6 and reflect him. So I know that that's a challenge. I'll give you a hint. There's going to be something in the front, something, and then your X for the straight line, and then something afterwards. So you come to class, give that to me. Let's see how it is. Go ahead and do these problems at the bottom without any graph, telling me what the shifts are, and also explaining the domain and range. Okay? In class, I'm going to ask you to finish up page 10. Check with me, make sure that you've got your vertical shifts down. And then the very last page, we're going to put it all together. I want you to do page 11 with a group in class. Make sure you're getting those right. Check with me. And then page 12, I want that one to be kind of on your own. Then you'll be study guide and test. I think you guys have this. Just remember, you're masters with the video games, now you're masters with math. We'll talk to you in class. Bye-bye.